Good afternoon, everyone. Thank you for all coming. I hope you all have enjoyed a lovely Easter break and a relaxing one. We have an exciting program today with 3 speakers. For those who don't know me, I'm Adelia Warris. I'm the Director of Training for the BRC. I am very happy to introduce 3 speakers today. So first we will have Professor Tim Harrower, who is a BSc Senior Investigator Fellow for the theme Neurodegeneration, followed by Chrissie Walker, who is a Research Manager and works in the Southwest Secure Data Environment. And then we will have a shorter talk from Ben Bowhay, who is a BRC PhD student. So just a little bit of an introduction for our first speaker. Professor Tim Harrower is, I need to do some housekeeping notes first. Sorry, the boring part. There are fire exits are down the stairs and out the main entrance. And there are some additional stairs as well, out the seminar room to the right. Nearest toilets just out the seminar room to the left. No fire drills, I think, expected. The tea and coffee are a little bit late, but there will be teas and coffees and lunch after the seminar. And we will also be recording the seminar, just to let you know. And then just to acknowledge that you are part of the BRC community with access to our capacity building, competition and infrastructure. And if you would like to find out more about what is available, please do get in touch with us or have a look at our website, which you can find easily by just NIHR Exeter BRC. And I think that is all what I needed to say. So over to our speakers. Professor Tim Harrower, thank you for giving a talk today. Tim runs an extensive research portfolio in MS, dystonia, and Huntington's disease, and there might be more. Maybe I didn't pick them up all. And he is a consultant neurologist here at the Royal Devon University Hospital, and also a visiting neurologist at North Devon District Hospital. And really looking forward to your talk, Tim.
Well, thank you. After that saying about the exits, oxygen masks will be available if I go too quickly. It's right, staring at me and tell me to slow down. So the title for this is Smart Enrolled Experts, and you'll see why it's that. It's kind of sort of cryptic in description, because the neurodegenerative projects I'm working on are firstly going to be MMD SMART, and I'll explain what SMART means. Motor neuron disease is the first part of that acronym. Experts in ALS is, again, ALS is a really terminology for motor neuron disease. And then finally, I'll talk about Enroll HD. So Huntington's disease, motor neuron disease, also ALS, are the classic neurodegenerative conditions other than Parkinson's disease and Alzheimer's disease, which the BRC neurodegenerative stream covers. So these are my disclosures. Of course, I've had the opportunity to represent myself and our work at various meetings and been paid for. Those are the clinical studies, and we are obviously going to spend time talking about the bottom 2, Huntington's disease and motor neuron disease, and particularly those 3 trials which I've alluded to already. So what I want to try and do is introduce or make the case for the SMART type studies. Well, what do I mean by SMART type studies? Because I'm very much a clinician, and I'm going to be very much talking about how we've embraced the difficulties around neurodegenerative conditions, difficulties around rarer conditions that are neurodegenerative in nature, and talk about some of the studies which are producing results and inform us about how to take things further forward with this. So I'm sure all of you will be aware of clinical trial studies. When you embark on a clinical trial, it's got to go through many different phases, and this is way through from animal studies and discovery, and then how to make the protocol, and have phase 1, phase 2, and phase 3 studies. And then if you're successful, you can have a regulatory review, and hopefully it's approved for use in the clinic on a Friday afternoon for me to give to my patients with motor neuron disease. And then, of course, there's some sort of post-marketing surveillance, which is going to be important to make sure that we don't kill people inadvertently with drugs which we've developed. The problem with this is that there's a huge demand for participants along the way. So, generally a phase 3 study is going to involve at least 3,000 participants. Now, that's difficult because on my books currently, for example, motor neuron disease covering the whole of East and North Devon, I only currently have about 50 people on my books. So how am I ever going to run a trial which is going to contribute to that? The other thing to say about it is it's hugely expensive to run clinical trials. And clinical trials are not only costly, they are very, very time inefficient. So, for example, starting up with an idea as to an agent that you might want to give to a patient, along the line, you're looking at about 15 years to having one drug assessed and licensed. Companies which are going to be involved in the sort of patient parts of this studies are going to invest a lot of money. On average, about £5 to £6 million that they're going to be putting into taking a drug from this phase right the way through to FDA approval. Now, that's really not good, particularly if it's a rare condition, and in particular if you've got no time. And by almost definition, time is not what motor neuron disease patients have. It affects many different things along the way, and basically what happens is there's breakdown and degeneration of the neurons, particularly the motor neurons, somewhere along the pathway here. And that's going to give rise to a whole clinical phenotype. And the prognosis can be as short as 5 months. So if I make a diagnosis, there is a possibility that in 5 months' time, this patient will not have that 15 years of wait until the drug becomes available. So this poses a very significant challenge to us in developing treatments. This is just also to say that, the prognosis and the long-term patients that are alive at a certain amount of time follows a catastrophic Kaplan-Meier curve survival. It is really bad. And so patients end up suffering, and once the diagnosis is made, currently we don't have anything to do. What really is the problem is we don't really know why this is going on. Now, there's been a lot of discoveries in terms of genes, and you can see a whole host of genes becoming available to test for, right the way from SOD1 mutation back in 1990 all the way through to the vastly numerous numbers of genes. Now, the problem with these genes is that your average sporadic patient that I'm going to see is not going to necessarily have a gene abnormality. Only about 10% of the genetic variants of motor neuron disease will probably have the SOD1 mutation. This means that to try and understand what's going on, although we've got some nice defined genetics, it doesn't actually tell us a great deal about what is going on. Therefore, targeting or generating a treatment is going to be hugely complex. Here, for example, are some of the theories about what happens to the motor neurons, and you can see that there's different categories of theories, large number of fitting in of those genes and telling us that it's this pathway, it's that pathway. But actually, at the coalface, dealing with patients doesn't really matter to them. Doc, can I please be on a clinical trial because I want to have something that potentially works? Ultimately, right now, what we end up doing is trying to provide the patient with support in all these different areas, and the current treatment options are evolved from some of our understanding about what goes on. And you can see on here, memantine, which I'm going to spend a bit of time talking about, trazodone, which I'm going to talk a little bit about, and then various other therapeutic options down the line. Now, which ones of these are good, which ones of these are bad, we just don't know. This is all hypothetical. This is pretty much cutting edge thinking from about 2 years ago, as in these are options, but do they really work and are they safe? Well, we don't really know. So saying that it's all bad news, well, actually, if you have the SOD1 mutation, there are some very specific oligonucleotide treatments for this, which is good news because it's telling us that actually you can offer something, but for the vast majority of patients, you can't. And this is a trial published in New England Journal using a drug called tofersen, which showed some benefit in ameliorating the genetic abnormality, the SOD1 mutation. Less about that, more about what we're doing. So MMD SMART is about a systematic, multi-arm, multi-stage, randomized, adaptive platform trial, therefore the SMART of the title. And it's run out of Scotland and mainly funded by Doddy Weir Foundation, but also signed to with the Motor Neuron Disease Association and more latterly the NIHR research. And this is basically trying to get access to clinical available treatments here and now for our patients. And actually also taking a step of getting rid of those things. So for example, memantine was up there as a possible. Patient's going to come to you and say, well, actually, I really want this stuff. Is it worth me taking it? I don't know until now, until we've got you involved in the study or whatever. So the idea with MMD Smart is to repurpose drugs which we currently know are effective in other clinical spheres. In other words, repurposing what's already. So if you remember this long process around here, the idea would be that we come in with a phase 3 study, testing a drug which has been through all these phases for another condition and kind of hope that we'll get an answer by short circuiting this. So cutting it down to a year or two. The important thing about this trial, this multi-adaptive study, is that actually it's recognized by the authorities like the FDA and the European Union Medical Agency to be a viable way of getting a drug repurposed. Now, what I mean by multi-arm means that they actually, as it goes on, you can see, for example, this is an old study, Stampede, it's a prostate cancer study. They needed to answer questions about what else other than the standard treatment could be offered. Standard of care is the baseline, or what we're going to call the placebo, and then you add in multiple arms of different treatment choices. You can see that aspirin, or where was that? Yeah. Well, one of them is that you actually got these drugs which are already purposed for something else. And you run this over time, and if you can look at this study, it's years and years of data have been accrued. But ultimately, these ones here are terminated because they're found to be useless. There's no benefit to being on these additional agents. So you then move on. The adaptive part is to stop early, publish that, and say, don't bother with that ever again. But maybe we've got a new development, maybe there's a new treatment, and this adaptive part about it is there. You've also got the randomized bit, the sort of placebo arm, as it were, as a reference point all the way through. And so this is what we mean by a multi-arm, multi-adaptive study. And SMART is one of those, which is run from Edinburgh, that you can see the centres across the UK who are taking part in that. And where have we got to so far? Well, we got to the stage of testing out a number of agents, memantine and trazodone, which I mentioned on that list earlier on. And at this point in time, I can safely report that these are not useful drugs. They should not be offered to patients because they provide no benefit. And we've got to that answer within about 2 years. That allows us to move on to the next generation, the adaptive part, to try and find a better option for these patients. How did we choose which arm of therapy was going to be part of it? Well, we did a data call and we went through all the publications. And this is a nice example of looking at all the different avenues of previous drugs, and we can work out how they work potentially and make a list and have a drug score of what might be a useful option to try. So there, for example, is memantine, referencing my earlier slide. We needed to know, is this worthwhile offering your patient or not? And we can cut out some of them because of various reasons to exclude them. These are the drugs which we threw on the pile of don't go there because they're not really useful. Lithium previously had been tried and kept on coming up as one we should try, but actually previous examples of it were pretty useless. And so on to now, this is the sort of the protocol in the initial phase, or the first step in it. The first arm was we had these two drugs compared to placebo, and this was published just last year in MD Smart, and the outcome measures in this one. Now, this was quite a longer study. It was more than the 5 months. But of course, there are going to be some people who, when they've signed on to this, are going to pass away. So one of the outcome measures was, in fact, death. That's quite a hard thing to say, really, but it is true. People are going to die with motor neuron disease, with or without treatment. Can we have a clinical scale to see whether the motor neuron disease is getting any better? Yes, we've got this thing, the FRS rating scale, and you can see that there's no difference between the two trial drugs and placebo, and the Kaplan-Meier's continue to show a deterioration and unfortunately, yeah. So the upshot of this all is that when we looked at this in more detail, it wasn't really useful to try these options. Good theory, but probably not really useful. And so what we can end up saying after this is that neither memantine nor trazodone improved survival rate, improved any of the outcome measures that we were testing for, and actually have caused some side effects. See them down there, which would mean do not offer your patients this. So that's a negative result, but actually quite important because patients want to know whether they should have memantine or not. The answer is no. Now, most clinical trials, if you've spent a whole lot of money developing this, and say, for example, you're Roche and you have a drug and you want to go through all that stage and you've spent your 5 or 6 million and you've spent a lot of some time and you get a negative result, generally speaking, companies don't want to publish that. They want to keep that away. They're not associated, don't want to be associated with failure. And in the element of disclosure, a nationally funded project like this has to have the negative results published. It's part of the deal. Where are we right now? So this is the email I got this morning. So MND Smart, we're now heading on to the next arm where we're going to try tacrolimus, which is in setup, and some of the patients in Edinburgh, the home centre, are already on that just recently. And total, we've got about 940 patients so far in MND Smart, including that first phase where we found that memantine and trazodone were not helpful. So then comes the next bit of this. So we've said that we've had an outcome measure, which is not a great thing. Can we be better than that? Can we actually look for some marker, biochemical marker, for example? And yes, we can. We believe that neurofilament light chain would be an ideal screening tool to determine whether a drug is going to be helpful or not. And experts, I'm not so sure I feel comfortable calling it experts, but that's what it stands for, Experimental Medicine Route to Success in ALS. And this is run out of Oxford and Sheffield, major centres of expertise in England for this. And it is based on the BRC systems or networks. And you can see us down on the bottom there. And this is going to look at the outcome measure being neurofilament light chain. Now, usually when you're measuring neurofilament light chain, it's typically often measured in CSF. It's a bit unfair to ask these patients to come in and have regular lumbar punctures. So the breakthrough with this study is that we've actually been able to commercially and reliably, reproducibly undertake neurofilament light chain assessments. The idea being that you've got a drug, put the patient on neurofilament on the drug, and you measure their blood sample for neurofilament light chain at various intervals. And if you show that the neurofilament light chain is going down, that's telling you that your drug is some sort of neuroprotection or beneficial. And then it can feed into other studies like MND Smart. And where's this got to? Well, we've got it all going, and there's a number of work streams which come out of this. So obviously looking for a drug, that would be good. We're looking at how we can prioritize which drugs to put into the system. So in a similar way of calling all the data about drugs which could be useful, that's going on as work stream 2. And then work stream 3, almost skipped over it, because the most important part for us is to look at various biomarkers, including genotyping and phenotyping of the patients. And this is where John Mills, Emma Debs, and us here in Exeter are on the table, where we're looking at genotyping and looking at epigenetic features of this condition. Now, the feedback from all this is that we started to accrue those samples, but in the meantime, we've tried our best to get it up and working for us. And we've done this study called NeuroAS, which is just a sample of blood, an extra sample of blood for anybody that comes to my motor neuron disease clinic. And we can put that in through the lab and hopefully get an idea about the epigenetics. So this is not yet, I've got nothing to say about this just yet, but it's up and running, and we've already recruited quite extensively to this. The more astute of you would have realized that the NeuroAS MD is motor neuron disease, and I'll talk a little bit about HD now. So that's a bit of a break. Any questions about motor neuron disease and clinical trials? What about Huntington's disease? This is a passionate area of my personal interest with patients who have this condition. Now we know what the cause of the problem is. This is unequivocally as a result of CAG, autosomal dominant nucleotide repeats. So if you have more than 36 repeats of this particular Huntington gene, you're going to get Huntington's disease. And basically it ends up with motor impairment, the career of Huntington's career, cognitive impairment, and often psychiatric components. So it's quite a multi-pronged problem. And what ends up happening is the brain dies back. And the brain dies back in a neurodegenerative way. And the most impactful part about this is what happens to the caudate nucleus. Don't worry too much about the anatomy. But that's the part of the brain which has an effect on controlling your movements. And when you lose the caudate nucleus, you get chorea. And chorea is just like looking at somebody who's a bit fidgety. This is about the CAG expansion on the gene, chromosome 4, Huntington, and it gives rise to the problem. And we know that that's the problem. It is unequivocal. You can't argue with that. But how does it actually happen? So we're in that same sort of quagmire of, well, we know that the gene is abnormal, but actually what ends up causing it. So again, we're in that realm of, well, if we don't really know how this is happening, then can we develop treatment? What we do know is that the gene is abnormal. And nowadays, with CRISPR and oligonucleotide therapies, we can hopefully lower the mutant allele of Huntington. And this is clinical trial work which is ongoing, and time will tell. In particular, using CRISPR, it's going to be a very, very useful way of looking at this condition. So basically, HD abnormal gene, bad message, bind an oligosense nucleotide to it, get it destroyed. You don't produce any of the abnormal Huntington, therefore you don't get any of the disease, is the idea. And we're looking at using gene editing with CRISPR, hopefully in the future. What about here and now, though? And this is, again, the enroll part of the three-worded title. Well, Huntington's disease has been very, very well looked after in terms of platform studies. And Enroll HD is undoubtedly one of the better studies and extremely well funded across the world. So apparently to the tune of about $100 million per year to keep this going. And these are the centers across the world who are taking part. We're down here somewhere, and we've got quite a few patients involved in it. And this is a really good platform study. We are starting to have clinical trials, but this has been much more useful in terms of gathering data about what happens to the phones. So currently, this was downloaded, I think, yesterday, 21,000 patients currently worldwide. And what this means is that these patients end up having regular assessments on a yearly basis of cognition, motor function, psychiatric, behavioral things, and also we take a biomarker sample of various stages along the way. This is just to show you that it is kind of truly a global endeavor. See the enrollments. This is total enrollments. The difference between that line and the active line is unfortunately people also die as a result of this condition, but much more slowly, 15 to 20 years after diagnosis post-op. And there's a lot that we can gain from this type of study as platform. One of the things that we've done is we've looked at the quality of life issues here in the university with Professor Green and Annie Hilton. And, we've got a lot of information about that by tapping into this huge database. But importantly, and this is the reason I wanted to mention it today, is the access to biosamples as part of the study. So if you have a project and you're wanting to think about this, please let me know, because we can apply for the biosamples and it will be longitudinal. It'll be on a yearly basis. And we're hoping to be able to do a bit more in terms of the Maria Gelling's research, the imaging center, by scanning people at regular intervals and getting an idea of what's going on. The biosamples which we can offer as part of the study, and we can do it because we're taking part in it, includes CSF. So this is a case where often we have patients and we get them in and we do lumbar punctures. And we're the first in the world to have serially the first, I think we're into our fourth year, and we're the first in the world to have a fourth sequential annual sample of CSF to this database. This database is going to be slightly bigger in the near future. It's going to include sperm, in an interestingly named study, HD origin, because there's some theory that the expanded allele might be really problematic in sperm, and feces, but I'm not so sure that I'd be that inclined to want to take part in that. Yes, the data on Enroll HD that we can offer. And so if you make an application, you can get all this longitudinal stuff, and that, can be really helpful. So we focused in on health economics here locally some time ago. But then I said to you I was going to come back to NeuroAS. That's because the HD part, and we're also going to look at the epigenetics. Now, it's a bit strange. Doctor just said to me that it's an expanded allele. You know the problem. But actually, we still have some variability, and a lot of work is now going on to determine when you have an expanded allele, what affects how that's going to play out for your patient. What's the phenotype going to be like? So looking at the epigenetic phenomena is going to be vitally important. And Emma and John are helping us with that aspect as well. And I'm going to stop there unless there are any questions and just acknowledge various funding bodies and people that have been involved. Questions?
Thanks, Tim, for a great overview about all the clinical research going on in motor neuron disease and Huntington disease. Questions? Maybe I can start off. You showed a slide with all the different genes kind of related to ALS. Is there any genotype-phenotype association? And does the genotype give you any information kind of prognostic-wise?
So one of them, which I've glossed over because it's actually quite difficult to explain, is the C9orf gene. And the C9orf gene, if you know much about neurogenetics, is the gene which is involved in frontotemporal dementia. So if you've got that and you've got the clinical phenotype, you will end up with a catastrophic frontotemporal dementia on top of it all. So in that way, yes. But usually speaking, I can't tell a SOD1 mutation from somebody else unless I know the family history and I've got the gene. So usually it's quite opaque in that way. So not really.
Yeah, okay.
To answer your question.
Okay, thanks. Any other questions? Yeah, please.
Oh, sorry, Luke. Can I give you the mic so people online can hear?
Thank you.
Oh,
Is this working now? Yep.
Yeah.
Thanks. That's really fascinating. I love the idea of the adaptive trial there for motor neuron disease. My question is about, so for the drugs you've tried, you found on average that they don't have a benefit for the patients. But do you have a mechanism in place to find if there are specific subgroups of patients with certain characteristics or genotypes for whom the treatments are effective? I think you mentioned at one point that some of them are effective if they carry a specific mutation, for example.
Not currently. No.
Can you stand here for our audience online?
So not currently. That would be obviously really interesting. So if you discover somebody who's got the SOD1 mutation, you're going to take them out and they can't take part in the study because you can offer them metofosine, which is much more clinically useful for them and theoretically makes a lot more sense. Bad gene, get rid of the bad genes effects. And so it's very localized. Yeah.
Yeah, Michael.
Thanks, Tim. Thanks, that's a great talk. So you've nicely demonstrated the importance of the clinical community, including the community coming together to taking up findings treatment options for patients with rare diseases. In terms of funding, more questions, who's funded these studies? Has it been a combination of commercial?
So it's more than likely a central funding body. So the CHDI, I forget what the C and the I, but it's for Huntington's disease, is extremely well funded by a benefactor from the United States who wishes to remain anonymous, to the tune of 100 million per year, which just means that that's fantastic. So, you know, every time I do an assessment, for example, motor neurons, motor rating scale, apparently we earn €100 for our department. So it's well funded in that way. And that 100 million is apparently for good. Motor neuron disease, on the other hand, has been extremely well funded recently. I think about 2 years ago, the government announced that they were going to put £80 million towards clinical trial work to be administered via the National Institute of Health Research, NIHR. And that's how come experts in ALS has come out of it. And that's how come it's been channeled through the BRC units across the UK. So, for example, currently, anybody who has motor neuron disease in Plymouth, our neighbouring sort of trust, can't necessarily get involved because they don't have a BRC. We are now hoping we're going to have a research nurse who will be able to pull those people, the appropriate people, in to our service. And if they need to go and do remote consultations and assessments, that's going to be the idea of it, because these people are not as mobile as we'd like them to be, of course. But the other things are the charitable fundings that are available from NNDA, the Doddy Weir Foundation are extremely well funded in their own right. So unfortunately, it's fallen on private sort of funding, but with the support and the administration via the NIHR.
Okay, thank you so much, Tim. I think we need to move on to our, next speaker. There will be time over lunch, okay? Our next speaker is Chrissie Walker. Chrissie works across the BRC and PENARC to improve access to healthcare data for research. She works with partners in universities, the NHS and aligned organizations to build and strengthen reciprocal research links, in particular through the support and development of the Southwest secure data environment. Secure data environment. Thank you. And looking forward to your presentation. Is it the next one? Yeah.
So just keep going. I had some idea.
Okay. Here we go.
Thank you. Yeah, I'm Chrissie Walker. I'm a research manager in health data, and that's really a focus on NHS data. And the reason for that will become clear during my talk. So my talk today is to introduce the Southwest Secure Data Environment. Some of you may be pretty familiar with it. Some of you may never have heard it. So I'm going to kind of go back to first principles and explain a bit of background and context, talk about the SDE from a partnership perspective, explain what secure data environments are for accessing health data, talk about progress and the future plans for the SDE. So the Southwest SDE really came about because of a couple of things that happened during 2022. So in April of that year, Ben Goldacre and Jess Morley wrote a report, commonly called the Goldacre Review, where they recommended, amongst a series of recommendations about improving the access to health data for research. One of the recommendations was to create a small number of secure platforms where people would go to access health data for research. And then that was put into government policy in June of the same year, where in that policy, it said that they would establish secure data environments as the default route for access to NHS data. I'd only arrived in PENARC in December of that year, so this basically taught me that all research to do with NHS and NIHR was incredibly efficient and went from idea to policy in a matter of months. So it's been a delight to carry on at that pace. Within the Southwest SDE, so following that June policy announcement, so money was made available across the Southwest. Groupings came together very rapidly, and it was led by Bristol, North Somerset, South Gloucester ICB. It had to be led by an NHS organisation, and they received funding from October 2022. So it all happened quite quickly. Since then, in the background, the SDE has been developing, but to give you that national picture, in November of 2024, Cathy Sudlow then released a review that basically emphasised that secure data environments were a good thing and that they should be supported. And she made a number of recommendations, one of which, that second one, to establish a National Health Data Service, will come up in a couple of slides' time, so just remember that one. In March, Keir Starmer went to Hull and announced he would abolish NHS England, which was a shock as an NHS England funded programme. We are actually sort of quite safe within our programme because of various backroom reasons, but what that has meant is that a lot of the people that we're dealing with across our partnership model are obviously under extreme duress, and so that has created difficulties within the programme. But we're working through them. And then this month, it's rapidly moving space. It was fantastic to hear that Wellcome are now moving into this space. So they've put up 100 million of their money to join up with up to 500 million of government money to bring into service this idea of a national health data research service. So that's going to now become the kind of wider umbrella of work that we will kind of contribute to. Nobody knows much more detail. It's all being worked out, but it's great to have Wellcome join in. So to introduce the Southwest SDE and its partners, we are a regional SDE that, as you can see on the slide, goes up to Gloucester, doesn't include Dorset, they're part of Wessex, but that's 11 subnationals covering the country and then one national secure data environment. And this work was all funded through the Data for R&D programme, which is part of NHS England. It's worth emphasising that the Southwest SDE really shouldn't be thought of as a sort of bank of servers in some secure corridor sitting somewhere mysteriously in the Southwest. It really is a partnership. We have spent the last couple of years building really strong relationships with not just NHS trusts and ICBs, but examples across this slide of significant data sets, health innovation networks, the councils, really beginning to surface all of the amazing data and activity that exists in the Southwest. This slide is almost certainly out of date, but this gives a sense of some of the examples of data controllers that we're working with that will be feeding data into the secure data environment as it comes online in the next few months. So the first wave of the green and then moving out into the second wave. This is all approximate, but it's just to give a sense. Really, we're working with trusts that are in a position to move quickly. So RDUH, for example, with a more established EPIC patient record system, are really keen. Other people are still setting it up, like Cornwall are setting up their Cerner patient record system, so they are not really ready to move quickly at the moment. This is our governance model. So we report into NHS England's Data for R&D board. That presumably will change at some point. The leadership board has representatives from our data controllers across the Southwest, so the trusts and the ICBs, a management team that meet weekly. And it's worth noting the sort of the 5 work streams across the bottom, all of which are absolutely crucial to the continuation of the programme. I work on the research work stream with Rachel Denholm, who's part of Bristol BRC. And alongside our Southwest, we also have very strong connections with the other southern secure data environments. And we've got a loose informal grouping that we call the Southern Consortium. And that's just really highlighting that there's a partnership where we work very well with these other SDEs to just make sure we're all on the same page and we can share problems and challenges as we come across them. So to give an overview of the generic secure data environment model, as everyone in this room will no doubt know, it has been very difficult to access data for research. So not very long ago at all, it would be traditional that you would find a friendly clinician working in the area that you wanted to do some research in, and they would tell you that they could get you some data, really. And that might be that they would post you a thumb drive and it would arrive and you would look at the thumb drive, open the data, and there would be identifiable patient data in there. And you really shouldn't have been sent that, but you now had sensitive data on your computer, or the clinician would say, yes, I can definitely get that data to you. And then actually they found out during the course, once the funding had arrived, they couldn't. So there's an awful lot of waste in health data research previously. Through secure data environments, the secure data environment sorts out the information governance. They understand their data controllers' data. They can tell you what is available and what is not. They can help you understand where you should be applying to get the data that you need. We're a single point of access. You don't have to go to all the different trusts that hold that data. You just come to the secure data environment, and we can help link you to data in our region, but also other secure data environments to look at that wider picture. We can also help surface data sets from within our region. So in Tim's talk, when you're talking about data sets that you're generating, it can be a route that you can be added to these catalogues, where you can then become much more aware of data sets that are being built nationally, potentially long-term internationally. It's really just about surfacing and making more visible the data that's available. Obviously, streamlining will hopefully reduce costs and will give you access to the software and tools that you need. They'll all be held within the secure data environment. From a researcher perspective, this would all be done through your laptop. So as a researcher within a BRC, you would gain accreditation relatively easily. That's all done nationally. You then log into the Secure Data Environment Gateway, have a look through the catalogues. This is all imperfect, but it will become more streamlined and perfect as time goes on. You will log into those data catalogues, have a look what data is there, put in the request. The data access committee for that secure data environment will hopefully approve your request. And at that point, the responsibility is all on the secure data environment to bring that data into the project container, where you would then analyze the data within that secure environment. So just some key points. It's useful to think about the Southwest Secure Data Environment as a paid for service, like you would the sequencing service or the high performance computing. It's something that you need to be adding into grants if you want to access NHS data for research. The SDE won't hold standing data. It is just on a need to use basis. So you tell us what data you want. It's pulled into that container for as long as you want it, and then it is removed. The data sets will increase over time. So as it's being set up over the next few months, the actual technical platform, the first data to flow through will be routinely collected data from the acutes, so from the hospitals, and then we will work out from there and over time bring in more and more data through that you'll be able to access through the SDE. So again, to really emphasise, please get in touch if you want to access data through the SDE, and please start costing us into grants. If you have significant funding for a programme grant, we can jump you up to the top of the queue as far as sourcing and prioritising any data that you need. We need to become self-sustaining over the next couple of years, so we will go where the research need is and where the money is. This is a technical diagram if anybody wants one. So basically the data flows in from the top left-hand side. At that point, it's identifiable. The patient data would have their NHS number as their identifier. Within the secure data environment, we link it using those identifiers. We then de-identify it, so it becomes linked de-identified data. It's then moved into that secure container where the researcher accesses it. It's there, as I said, for as long as the researcher has agreed it needs to be there, and then it is removed. So progress so far. It's worth noting this is an incredibly complex and difficult programme to roll out in an NHS that is time-starved, constantly in crisis, but we've got an amazing team led by Henry Ireland, who is really focusing on this as a relationship programme to keep everybody on side. Everybody can see the benefits of this. We've got CAG and REC approval. That means that we can pull in unconsented data for research. So this moves outside of the sort of trial data into all of the data that sits within our trusts and other organisations in the Southwest. Lots of public engagement. We've got agreement for joint data controller agreements. So again, that's backroom, very boring but very important stuff. That means that in the SDE, we'll be able to pull through data quite quickly and effectively. We're building our pipeline of research grants. So we've already got grants that have costed the SDE in, and they will begin to use the SDE for real later this year, which is very exciting. We've also developed a network for the Southwest, which focuses on people in the Southwest who use or access data for research. So that's predominantly NHS-facing organisation, where we want to work with partners in the NHS who are analysts, often in isolated roles, and bring them together to make them feel part of a community where they can talk and think about what the rollout of the SDE will mean for them. We've also launched a website that looks like that. It's currently not got much information on it really, but over time that will have all of the projects that are moving through the SDE will be able to be viewed and seen there. We really want to publicise what research money is being spent on in our region so people can see what their data is helping contribute to. So what next? The big news, the exciting news for the University of Exeter particularly, is that the Southwest SDE has funded 2 new clusters for the Southwest, one based at the University of Bristol and one based at the University of Exeter. For everyone in this room, what that means is there'll be a new team of people that will be sitting within Katie Finch's team in research software and analytics, and they will only be focused on research involving health data. So they will become the experts that can give you the latest news about what's happening with the SDEs, how you're able to access data, what the SDE can give you. We can help with that mix of roles. We've got the programme director coming to the University of Exeter, which is going to be a massive coup for us. Senior research manager, and an RDM. So we can help you write grants. We can help you find the data you need and really help speed up research applications in this area. Technical, what next? On the left is our minimum viable product, which was just proof of concept. We'll just flow some data sources through, moving on to the right-hand side, which is where we're really flowing data from lots of trusts, lots of ICBs, lots of other data sets. The next stage is continuing to raise awareness through talks like this, building our partnerships. We've identified 3 key areas that we really want to develop particular strengths in against the other regional SDEs. Healthy ageing, for obvious reasons. We're an older population in the Southwest. Climate, with the Met Office and our expertise at Exeter and clinical trials. We're going to release our MVP imminently. Flowing data, developing commercial models so that we can make sure that we can self-sustain for the long term, and also build our team, because it's been a skeleton staff so far, which has been difficult, but with the development of the 2 clusters, that should ease things quite quickly. Taking questions, but if you want to drop me an email at any point, that is my email address.
Great, thank you. Time for 1 or 2 questions. Sally?
Yeah, thank you, Chrissie. Great talk. This is a great commercial opportunity, and it's in particular a great opportunity. It's a great opportunity for phase 4 trials addition. Is that, how's government going to manage that? I mean, I think they see this as, you know, kind of a real jewel. Yeah.
Yeah, I think nothing is set in stone yet. Everybody knows where they want to get to. I'm not sure particularly. So Henry, the programme director, is in the room with us. Do you have any insider information?
I think yes, in short. So there's a national forum that's already engaged most of big pharma about how NSD to be front and centre in phase 4, big pharma project. For us, it's around maximising the immediate impact through patient benefit research, but it's been really clear that this is an economic growth initiative. So the idea is to try and get a lot of commercial industry partnerships that make the SDE self-sustaining to the point where we invest money into academic systems. That's the early studies that we've got that might be supporting regulatory agreements as well as post-market space.
Yes, it would probably be good for our clinical trials community to have a think about how it develops expertise in those areas alongside this investment in the data.
Absolutely. Yeah.
Angela?
I'm not sure it's working. Turn it on.
Thanks. Thanks, Chrissie. That was really great. Can you, I get confused because there are so many different health data things. Can you just explain where the Southwest Secure Data Environment fits in the Health Data Research Alliance for us, please?
Yeah, so the Health Data Research Alliance is something that the University of Exeter has just become a member of. And that is basically a talking shop, a community, a little bit like Sway, but at the national level, that's managed by Health Data Research UK. And it's a way to bring in people that are working in this space so that when the government says we need a policy on this or that, we've got the expert network where we can help shape those policies.
So it's not holding any data at all. The data is being held in the secure data research environments. And the other thing is just, as you said, a talking shop.
Yes, it's a place for experts to get together to help
Brilliant.
shape the backroom
Thank
stuff.
you. That's great. Thanks.
Quick question about, you said there is no standing data in the Southwest environment, or the
Secure data
secure
environment.
data environment. But if you pull data into it on request of a study proposal, how long will you only hold that for the period of the study granted, and then you will destroy it, or will in the end you build up a standing data collection?
Yeah, so one of our, we all want data studies, research studies to be reproducible. So one of the things that will happen, and this is, I'm not on the technical work stream, I'm on the research work stream. After a project is closed, it moves into cold storage. So the data that has been shared up isn't kept within the secure data environment. But if, for instance, somebody wanted to rerun that study, it could be pulled together.
Okay.
I don't know if it's that very gets into the technical realm that I try and stay away from.
Yeah. Okay, but you can access that identical.
Yes, you can understand the environment that it was done in and the data that was pulled in, but that data doesn't remain. Once your approval for that research project has ended, you no longer access that environment.
Okay. Thank you so much, Chrissie. We need to go on to our third speaker. Let me see if I can. Ben Bowhay, he is a second-year PhD student funded by the BRC, working in a great team with Owen Tomlinson, Craig Williams, Michael Gibbons, and Chris Cotton. And you have a very intriguing title, Chronotropic Incompetence. And I hope we will learn a little bit about that.
Thank you, Adelia. So yes, if we move on to the presentation, so an introduction to chronotropic incompetence. So I'm Ben Bowhay, a BSc physiotherapist, PhD student under the guidance of Dr. Owen Tomlinson, Professor Chris Cotton, Michael Gibbons, and Craig Williams. So for today, we're looking to understand what is meant by the term CI, chronotropic incompetence. We'll look into the potential reasons for exercise intolerance in this group and identify if chronotropic incompetence occurs within IPF, so that's idiopathic pulmonary fibrosis, which we'll discuss a little bit further. So chronotropic incompetence, so basically it's related to heart rate control by the autonomic nervous system and the balance of that. So during exercise, we have sympathetic activation with withdrawal of the parasympathetic nervous system, and that helps to increase the heart rate to meet the load. Post-exercise, the opposite occurs to decrease heart rate. So we can look at a range of different ways to identify if chronotropic incompetence occurs. So we do this by a cardiopulmonary exercise test, and that basically gives us a breath-by-breath analysis of the patient whilst they're exercising. So we can look to see if they've got a delayed heart rate response from the start of exercise. We can also look to see if they only reach a submaximal exercise performance. So that's in relation to VO2, so volume of oxygen uptake, or if there's a slow heart rate recovery following the bout of exercise. So firstly, with the delayed heart rate response, we can look at heart rate tracking and then comparison against a non-chronotropic incompetence group. If they only reach a submaximal exercise performance, then we can look at this by two different methods. So one is the Astrand equation, so 220 minus age, or the chronotropic response index. as you can see there. So with the APMHR, we're looking for kind of below 80% is that submaximal range. And then for the CRI, it's below 0.8. Also looking at the slow heart rate recovery. So this is linked to that parasympathetic reactivity. So we're looking at that heart rate recovery rate, and there's evidence to say that under 12 beats per minute heart rate decline is indicative of chronotropic incompetence. So this is just an overview of those factors and the ways that we can identify CI. So now we link on to my topic, so my condition, the focus of my PhD. So it's looking at interstitial lung diseases. So there's 200 of those. So in terms of subtypes, and it's basically related to fibrosis and inflammation within the lungs. So there's within the IPF population, so within idiopathic pulmonary fibrosis, which is a condition of unknown cause, there's an estimated 32,500 people within the UK. So it is chronic and there's no cure. And the factors relate to lung function decline and respiratory failure and mortality. So the median survival for IPF patients is between 2 to 3 years. And we look to hopefully slow the progression of this disease, maintain lung function as best we can, and improve these patients' quality of life. Now, to do that, we have some medications, fantastic, but we also have non-pharmacological therapies, which look at pulmonary rehab with structured exercise, advice, and education as the combination. So this has been looked at by the American Thoracic Society and the European Respiratory Society. So they actually encourage regular exercise training and PR to improve or maintain cardiorespiratory health and exercise capacity, alongside the British Thoracic Society, who again look to hopefully integrate pulmonary rehab to reduce the severity of these patients' symptoms and improve their quality of life also. So why focus on idiopathic pulmonary fibrosis? So we've done a systematic review, which has indicated that in IPF, for our topic, which is looking at tailored exercise prescription within this cohort, so within ILD, there are only 4 out of 12 included studies for this subgroup. At present, there's no exercise prescription guidelines that are detailed for the ILD or IPF populations. But also we found that there might be links towards chronotropic incompetence in this population. But at present, heart rate-based prescription is one of the main ways that we look to prescribe exercise. So it's important to identify CI in this population because there is evidence of exercise intolerance within research, and that would essentially impact on exercise prescription. And that would have associations with poor health outcomes and reduced survival rates if we can't quite get this right. So it's really good for us to research this and to see if we can improve exercise, improve PR prescription to hopefully help with those poor health outcomes. So within healthy individuals, so this is the typical heart rate responses. So VO2 uptake increases 4-fold, and this is achieved by cardiac means, so heart rate, stroke volume, oxygen difference increases. So the increase in heart rate is actually the strongest contributor to perform sustained aerobic exercise in healthy individuals. But within the IPF population, we can see that abnormal heart rate responses do occur within research, and they might be as in relation to these factors detailed. So pulmonary hypertension, circulatory impairments, medication use anxiety, but also chronotropic incompetence or autonomic nervous system dysfunction. So we've looked to research this a little bit further. and delve into if it occurs and the potential impact on exercise capacity. And we've been fortunate to actually have an abstract accepted to the ARTP conference in Glasgow coming up next week. So this is retrospective data that was analysed for 16 patients with IPF who performed the cardiopulmonary exercise test. And then we applied the CI identification, so looking at that chronotropic response index, and then categorized them into two groups, so either CI or non-CI. And we found that FVC and heart rate max, there were significant differences between those two measures, and potentially ventilation is quite close to that p-value as well. So we perform those independent t-tests and correlations between. So here you can see it's more of a visual representation. So we can see that quite clearly the CRI is lower in those patients with chronotropic incompetence. Then we look at how VO2 peaks, so that's the marker for aerobic capacity, was found to be significantly reduced compared against the non-CI IPF population. And then we found a medium but non-significant positive relationship between CRI and VO2 peak. So balancing back to prescribing exercise using heart rate, now in clinical practice, we would tend to get heart rate max, so that's the highest point at which a patient achieves in their heart rate outcomes during an exercise test. And then we would calculate, say, 50, 60, 70, 80% of that, which is common practice within research as well. We've actually found that the baseline measures for heart rate max, 50 and 60%, were actually not met by the majority of patients, so IPF patients. And this isn't related to chronotropic incompetence. This is just across the board. Whereas 70 and 80% heart rate max, the patients would be able to exercise at these thresholds from the beginning. So essentially, we would look to investigate this further by putting it into practice, potentially with a lab-based study. So in conclusion, we found that CI does occur in 38% of IPF patients, and they consequently demonstrate reduced VO2 peak, so aerobic exercise capacity. So we feel that heart rate-based prescription may need to be modified in this group due to CI. And then future studies, we'd look to investigate how heart rate-based exercise prescription can be modified. And potentially we'll look at using the gas exchange threshold, as this could enhance heart rate-based exercise prescription. So we look at that kind of swing between moderate and heavy intensity exercise, and that's where the gas exchange threshold would sit. So we would look to calculate that by the cardiopulmonary exercise test, individualized and tailored for these patients to hopefully improve their outcomes with exercise tolerance. So just a session overview. So we've defined CI, we've explored the potential reasons for exercise intolerance, and we've identified that CI does occur in people with IPF. And thank you very much.
Thanks for a very clear presentation. Questions? Time for one question. If not, can I ask, chronotropic incompetence, it's not associated per se with poorer lung function, because in your graph, the ones with CI had lower lung function. But is there a relation, or can that be, is that a separate thing?
I would say it's too early to tell.
Okay.
So we'd look to hopefully explore this further. It's one of the first studies that's actually looking to identify CI and then the reasons for the exercise intolerance off the back of that. So hopefully we can uncover that as we go along.
Okay, good. Thank you so much. We are at the end of this session, so there is lunch outside. Please stay for lunch, have a chat, or ask some additional questions to the speakers. And thanks all for coming.